What is really a worrying observation to me, actually, is that we've looked a bit for radio signals and we look out for signs of anything out there in our galaxy, intelligence, and we don't see anything at all. And astronomers call it the Great Silence. It's kind of an ominous name, but because it seems there's so many planets, 20 billion potentially Earth-like planets in the Milky Way, you think there's loads of room, and there's loads of time, so there should be things out there, but we don't see anything. The explanation probably, if indeed that's true, is biology. It's just, if you look at the history of life on Earth, it took nearly 4 billion years from the first cell to a civilization. 4 billion years nearly. That's a third of the age of the universe. And so I think the best guess is that we're so incredibly fortunate to be here, because it's just that ask that you say, I want a planet to support an unbroken chain of life through all this violence in the universe, an unbroken chain of life for 4 billion years in order to get to something like you and me, us, right? Collections of atoms that can think. I think it's just really unlikely. And that it's terrifying and also kind of uplifting in a way, isn't it? Because it means that we're unbelievably valuable.
One proposed solution to the Fermi Paradox is the rare Earth hypothesis. According to this hypothesis, the conditions necessary for complex life to develop are extremely rare and unlikely to be found on other planets. It suggests that if you take into account for how long it took on Earth to get to where we are today, Earth had to possess a unique combination of vital factors, such as a stable climate, a protective magnetic field, and an abundance of liquid water, which played a crucial role in facilitating the evolution of intelligent life. Scientists, however, are actually hoping that the rare Earth hypothesis is proven wrong. If it turned out to be correct, it would imply that the emergence of intelligent life is highly improbable and that we might be alone in the universe.
I touched on this in the live shows, actually, that where is the Great Filter? Let's assume that we are the only civilization around. Is the filter in our past or our future? So if it's in the past, as you said, it could be the origin of multicellular life. So single-cell life, fine. Multicellular organisms, not fine. So we've gone through the Great Filter. We're very lucky. Or the filter could be in our future. So it's very difficult for civilizations to go through the industrialization process, and they just don't. So there were lots of them, and they all stopped about now, which is also a possibility. So obviously we hope the filter's in the past.
Another fascinating idea proposed to explain the Fermi Paradox is the concept of self-destruction and great filters. This theory suggests that advanced civilizations, as they progress technologically, may face existential threats like climate change, nuclear war, or uncontrollable artificial intelligence that eventually lead to their downfall. However, as Brian Cox mentioned, we could have gone through the Great Filter by the emergence of complex life from single-celled organisms, a critical step in a civilization's development. If this transition is rare, then our successful evolution to intelligent beings could mean that we've already navigated a substantial part of the Great Filter. However, the possibility of future challenges remains uncertain.
Essentially, everywhere we look, every star we look at appears to probably has a planetary system. So there are a lot of planets. So life on them, how could we detect that? Well, we're at the level now where with our telescopes, we can look at the light. So you imagine a star and you imagine a planet passing across the surface of the star. Then the light, some of the light from the star passes through the atmosphere of the planet on its way to our telescopes. And that allows us to analyse, to chemically analyse the planet's atmosphere. So we can look for signs of life in the atmosphere. An example on Earth would be oxygen. So the oxygen in Earth's atmosphere, virtually all of it, comes from photosynthesis. Without photosynthesis, we wouldn't have an oxygen atmosphere. So if you see a planet with an atmosphere filled with gaseous oxygen, then you might be pretty confident that there's photosynthesis on that planet. So we have the chance, at least now, of analysing the atmospheres of these planets to look for life on them. The life on Mars, we're looking for that very seriously. Why? Because we think there's a chance that certainly a chance that it did exist at some point in the past, because we know water flowed over the surface of Mars. But we also strongly suspect that there's water below the surface of Mars now. And so any microbes that evolved perhaps many billions of years ago could have survived subsurface. So we may find life on Mars. So I think that's potentially one of the great discoveries that it's a guess again. It's not a particularly scientific thing to say. The reason we build big spacecraft to go and land on Mars is because we want to look. So we don't know. If we knew, we wouldn't go and build a spacecraft to go and have a look.
The anticipated discovery of life in our solar system is likely to involve microorganisms, given the extreme conditions of these celestial bodies. Microbial life, such as bacteria or archaea, is better suited to survive in harsh environments with limited resources. Mars, for instance, currently experiences extreme cold and a thin, unbreathable atmosphere. Any life that might have originated or survived there is likely to be adapted to these challenging conditions and could exist in the form of microorganisms beneath the surface, where conditions might be more stable and protected from harmful radiation. However, that may not be exactly the same to say for some of the moons in our solar system like Europa, Jupiter's moon.
So I wouldn't be surprised if there are aliens below the surface of Mars, right? Martian microbes. We've got a mission. I saw it being built. I was so lucky. About a month ago, I was in the Jet Propulsion Lab in California, where they build these spacecraft in that lab. And they've got one in there called Europa Clipper. They're going to launch to Jupiter's moon Europa. That's a frozen moon, about the same size as our moon, but it's ice. The whole surface is ice. And below the surface, there's water, salt water, sodium chloride in the water. And there's more water in there than all the oceans of the Earth combined, about 3 times as much. And so that's a candidate for life. And so we're sending a spacecraft to look for life. So it's not bonkers to suggest that life may have begun somewhere else other than Earth.
NASA is in the process of readying the Europa Clipper mission, scheduled for launch in October 2024, with an anticipated arrival at its destination in 2030. The mission's blueprint involves an extensive 4-year phase dedicated to scientific observations of Europa. This moon, exhibiting compelling indications of harboring a subsurface liquid water ocean beneath its icy exterior, holds a prominent position as a prime candidate for thorough exploration. Although it's clear that Brian Cox's most compelling explanation for the Fermi Paradox aligns with the rare Earth hypothesis, as we previously deliberated, and he summarizes it beautifully.
There must be other civilizations somewhere in the universe. There are 400 billion suns in our galaxy, and there are 2 trillion galaxies in the observable universe. So clearly, there has to be somewhere. The question is how far? And actually, when I speak to biologists, it's interesting. If you look at the history of life on Earth, there's an unbroken chain of life. We're all related to every living thing on the planet. The origin of life is nearly 4 billion years ago on this planet. But it took most of that time to put a civilization on the planet. 4 billion years, a third of the age of the universe. And so it's possible to argue that there may be very few civilizations out there in a typical galaxy. And I'd say, often I'd say a good working assumption is there's one. And that's actually a very powerful and important idea.
Thanks for watching. Please consider subscribing to our channel. I would love to hear what you guys all think about this in the comments below.